Everything around us is made of particles called atoms. Even though they are too small to see, atoms contain a large amount of energy that holds them together. This is nuclear energy. Energy can be released in two ways, either by splitting some atoms or fusing them together. We generate electricity all over the world using nuclear energy today by splitting atoms. When we split them, atoms release part of their energy as heat. This process is called fission. During fission, two or more neutrons, smaller parts of an atom, are released along with the heat. These neutrons may hit other atoms, causing them to split as well. Under the right conditions, small atomic parts continue to collide more and more. This is called a chain reaction. Trillions of collisions per second are necessary in a chain reaction to produce the high heat and pressure needed to generate electricity. In nuclear fission, the process is much faster than we are showing it here. This is the reaction that takes place inside of a nuclear energy facility. We use the heat that comes from split atoms to turn water to steam. The steam then turns a machine called a turbine, which is attached to an electromagnet called a generator. This process produces the electricity we rely on to light our homes, power our electronic devices, and connect our businesses. Nuclear energy can come from splitting different kinds of atoms. Few natural elements have atoms that will split in a chain reaction. Because it splits easily and can be found in abundance on the Earth, uranium-235 is one of the elements most commonly used to generate electricity from nuclear energy. Many places that generate electricity from nuclear energy do so with uranium. When we split a uranium atom, it releases 10 million times the energy as the burning of one atom of coal. For that reason, nuclear energy facilities require far less fuel than power plants that rely on fossil fuels. 1 ton of uranium generates more electricity than several million tons of coal or several million barrels of oil. In a nuclear reactor, metal rods with enriched uranium pellets inside are placed into bundles, creating a fuel assembly. The bundles are submerged in water inside a pressurized vessel. The two most common types of nuclear reactors are boiling water reactors and pressurized water reactors. In a boiling water reactor, the heat from split atoms causes the water to boil, producing steam that drives a turbine. Afterwards, the steam is converted back to liquid water and returned to the reactor core. Pressurized water reactors, or PWRs, were developed after boiling water reactors and work in a slightly different manner. In a PWR, the water in the reactor tank is under pressure to keep it from boiling, even though it reaches very high temperatures. In the steam generator of a PWR, water passes through thousands of small pipes. The heat in the pipes turns the water to steam, which then drives the turbine. The turbine powers the generator, which in turn produces electricity. Here is where the process differs from a boiling water reactor. The reactor water is now pumped back into the reactor tank and heated again. The steam from the turbine is cooled in a condenser, and the resulting water is sent back into the steam generator and heated again. Nuclear energy, part of a bright future for our people.